polynomials. Zeros are the x values that make f of x equal 0. Now let's talk about the types of zeros we could have. So if I had this function, and these are my factors, x minus 2, 2x plus 1, x squared minus 2, and x squared plus 9. So this is completely factored out. If I were finding my zeros, I'm going to take each of those factors and set it equal to 0 and solve. Well, the first two are easy. X minus 2 equals 0, I get x equals 2. 2x plus 1 equals 0, I get 2x equals negative 1, x equals negative 1/2. Both of these are what we call rational zeros. They're numbers that are easy to find. I could even maybe find them on a graph or on a table. But these other two aren't so easy to find. So if I took x squared minus 2 and set that equal to 0, then I would get x squared equals 2. And I would have to take the square root of both sides, and I would get two solutions there. Positive square root of 2 and negative square root of 2. Sorry about the bells. Again, square root of both sides, and we get plus or minus the square root of a negative number. Now remember, the square root of a negative number is imaginary, and that's actually going to give me the square root of 9 is 3, and because it was negative, it's going to get an I. So this one is imaginary, and this one is what we call irrational. Neither one of these I could find just by looking at a graph or at a table. These must be found algebraically. It's the only way to find them. Now there is something that can help us find our solutions, our zeros, and it's called the rational zero theorem. And what it does is it helps us find our possible rational zeros. And our possible rational zeros will always be the factors of the constant divided by the factors of leading coefficient. So let's just take a moment and find all the possible zeros of f of x equals negative x to the 4th plus 3x squared plus 4. So the possible zeros, I'm going to take the factors of the constant divided by the factors of the leading coefficient, and that's really a negative 1. So I'm going to be taking the factors of 4 divided by the factors of negative 1. And each of those could be positive or negative. So factors of 4 would be positive or negative 1, positive or negative 2, positive or negative 4. And the factors of negative 1 are just positive or negative 1. So I'm going to take each of those factors of 4 and divide them by the factors of 1 or negative 1. And so 1 divided by 1, 2 divided by 1, and 4 divided by 1. So positive or negative 1 could be a 0, positive or negative 2, and positive or negative 4. Same thing. So we're looking at the factors of the constant divided by the factors of the leading coefficient. So the factors of 2 are just positive or negative 1 and positive or negative 2. For 15, I've got quite a list. 1, 3, 5, and 15. So to come up with my full list, I've got to take each of these and divide by each of the ones in the denominator. So 1 divided by 1, 2 divided by 1. Now I'm going to go through again and divide by 3. One divided by 5. 2 divided by 5. 1 divided by 15. And 2 divided by 15. All right. Now let's do the full routine. This is called the rational zero test. Step 1. Identify the number of zeros. How many are we going to be looking for? Two. List possible rational zeros, which we just practiced. Check to see if any are zeros. Now the fastest way, if you happen to have a graphing utility, a calculator, is to look in the table. Now if you don't have that capability, then you could also test with synthetic division. And that's what we're going to use in here. Now I could narrow down my options if I had a calculator, but if I don't, then I can't. So let's make this example 3. And we're going to find all of the zeros. so the first step is to figure out how many zeros I should have. Well, since this is an x to the third, we should have 3 zeros. Step 2, list out all the possible zeros. So I'm going to have all the factors of 6 divided by the factors of 1. Well, that's kind of easy. That's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, if I was able to have a calculator and check for the zeros, I could check them in the calculator, look at the table. But since I'm not, I'm going to do this a little different. I'm going to use synthetic division to test. Now, if it is a 0, my remainder will be 0. So I'm going to start with 1. And let's list out our coefficients. 1, 2, negative 5, and negative 6. 1 times 1, add down, multiply, add down, multiply, add down. I have a remainder of negative 8, so this is not one of my zeros. But negative 1 is. So this means I already have a factor. I know that x plus 1 is a factor, negative 1 plus 1, and that this is x squared plus x minus 6. So I can actually factor that. That would be x plus 3 and x minus 2. And if I set each of those equal to 0, I get x equals negative 1, which is what I had there. This would be x equals negative 3 and x equals 2. Look how both of those were in the list of possible solutions. And I found all 3. Next example. Okay, so the number of zeros is going to be 3, and my possibles are going to be the factors of 3 and the factors of 1, so 1 and 3. Multiply, add, multiply, add, multiply, add. That's not one of them. Multiply, add, multiply, add, multiply, add, not one of them. Multiply, add. Multiply, add. Multiply, I know this isn't going to work. And y'all are missing a rainstorm here. Multiply, add, multiply, add, multiply, add. I found one. So this means my factors are x plus 3, because that would give me a solution of negative 3, and x squared plus 4x minus 1. Now, since I've tested all the other rational zeros, I know this will not factor. The only way I'm going to be able to solve that or find the zero that goes with it is by using the quadratic formula. So b is 4. A is 1. C is negative 1. All over 2 times A. So that's 16. That'd be a plus 4, so that's 20. Now, that is an okay answer. It's not the best way to leave it. I'd much prefer to simplify that radical, and 20 is 4 times 5, so that's 2 root 5. And I could actually go another step further here because both of these are divisible by 2. So negative 4 divided by 2 is negative 2, and 2 divided by 2 is 1, so that's 1 root 5. So I have these solutions, and let's make sure we have 3. This is 1. This is technically 2, because it's negative 2 plus the square root of 5 and negative 2 minus the square root of 5. That's 2 solutions, so I have found all 3. All right, so step 1, how many zeros should we have? We should have 4 zeros. Step 2, the possibles would be the factors of 6 over the factors of 1, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And so I'm going to start with negative 1. I'll give you a hint. One reason I'm starting with the negative is because that is negative. One times negative 1 is negative 1. That's a negative 2, 2, 3, negative 3, negative 6, 6, 0. Now what I'm left with is x cubed, so this is x plus 1 times x cubed minus 2x squared plus 3x minus 6. That doesn't factor easily. So what I can do now is take what's left and start going with the other possible factors till I break it down even further. Let's see. So I'm going to kind of, let's go, since that is negative, let's go with our next, well, let's just go back in line. Let's just do it in order. So I'm going to take 1 and go into what's left. This is repeated division. And I'll do 2. found one. Yay! Okay, so x plus 1, and that's going to be x minus 2. And this is actually going to be x squared plus 0x plus 3. So it's x squared plus 3. So when I set each of those equal to 0, I get x equals -1, x equals 2. This is going to be x squared plus 3 equals 0. So it's going to be x equals plus or minus the square root of 3i. And I do have 4 solutions.